Swayam Prabha. Digital India. Educated India.
Now, to draw this, you guys, some of you guys, you guys put in some hard work, and whatever the score you would see over there is going to get added up as extra credit in your total. So you have taken the pain, therefore there will be some gain for you. Okay? So those who did not, those who did, okay? All right, so I'll start from, bottom up. So this is the first result. Wasn't quite sure what he did, so he did not get much marks, but that's okay. Second, it's too large. And vanishing points and station point and horizon line, they weren't clear. Third, Virendra, is he there? Virendra? Okay, so maybe you took me too literally. So I said, well, just stand by your door and see how your room looks like. So you stood a little far from the door, but that's okay. As an art, it's wonderful. It's great. So possibly Virendra is standing over here, and he's honest. He shows what he sees. Yeah. Deepak, he took me too literally, so he went far. Deepak Kumar. Is he there? Deepak Kumar. So not only was he standing a little away from his door, maybe he went all the way up to the terrace of his hostel, and he is looking at his room from there. So that's okay. That's also art. Quite detailed. But I wonder what this is. Is this one of the home assignments or classwork assignments? Jitesh Mohan Kumar, are you there? Huh? Was this a homework assignment or a classwork assignment or? Okay, but your drawing is quite detailed. Wonderful. But that was a 1-point perspective. Huh? Well, what you showed was a 1-point perspective. Good enough. So in some proportion, the marks that you have gotten will get added up to your total. So you'll only gain. Ravi Kumar, is he there? Again, a single point perspective, but wonderful. Hardik Soni, not there, gone home. Pretty nice. He started off with a side view, a profile view, a top view, and he pretty much drew this perspective, 2-point perspective, but he decided to somehow work with lines. A table would have a little, so it won't have any thickness, but line, but that's okay. So, huh? Which one? This one? No, but if you look at this table, so these are possibly rods. That's okay. That's okay. So, Akash Deep. All right. So you also did a pretty nice job. Started with the top view, profile view, detailed drawing of your room. Pretty nice. So quite a few sessions that we have. Samir Raja. Okay. Pretty nice. But again, I mean, looks like you're working with the lines. You could have shown some thickness, that's okay. Shubham Agrawal, nice effort. Naveen, pretty nice effort, detailed, and you prefer to shade, so nice. So, you know, just look at the drawing and appreciate the amount of hard work some of you have put in this, and I really appreciate that, so thanks very much. Aman Rusia, okay, so he starts with an 8, pretty nice, detailed drawing. Ravi Raj, okay, pretty nice. Height information, so that was something that I guess had you shown that clearly could have been a little better. Yeah, pretty nice, very artistic. Huh? What about the scale? No, that was a 1 point perspective. That's the reason why I would have gotten a, yeah. So this is a 2 point. Was it? Which one? Yeah, but it hardly shows anything. Yeah, well, the scale is too large, but then where are the vanishing points and stuff like that? So, and by the way, so I did not grade them, so I asked one of my colleagues to help me out with that. So, all right, so missing things. Yeah, that information. So, and then of course the details, top view and the profile view. Had you shown that, you know, things would have been a lot better. But still good enough. I mean, 8, pretty artistic. Sunil Chaudhary, all right, so pretty nice again. So start with details and end up with a pretty nice figure. Once again, I guess you tend to choose lines. Yeah, so had you shown some thickness, things would have been a little better. Ish Kumar Jain, pretty nice. So he's the first 9. So no. There's a little story behind this. This person used 2 sheets. So this was the background sheet that he used, and his second sheet was this. Pretty nice. So I'm very glad to see some artists coming out of this class. So very nice. Arpit, yeah. So looks pretty nice, but somebody else wins. So the picture is not very clear, but if you look at the sheet, I'm not sure if we have the sheet here. Mohit, call it luck or what? I mean, Sonu has a pentagonal room. So she starts with a pentagonal top view, pretty much all the detailed information, the profile view here, and one thing that possibly went to her favor was that she was able to show that, you know, there's another vanishing point, the third vanishing point. So technically it was pretty good and it's pretty neat. You know, for quite some time I was pondering what should I give, and The best thing that I could give you is which I'm giving, ain't I? I am giving. Yeah, so more marks. All right. Huh? A. Star. Okay. Well, let me wait till your NSEM exams are over. I will be, and trust me, I will be eager. I will be eager to give as many A's as possible, but I need your support for that. So if you do well in your NSEM exams, I'll be very happy to give you A's and many A stars. But if you do not do well in your exam, I won't have that support that I am looking for. So if you promise me that support, I promise you the grade. You give me support, I give you grade. Yeah? Okay, so auxiliary views. So quite a few would have gone home, I believe, but that's okay. We discussed a simple example last time, so many of you were not here, but for your benefit, I'll probably go through this again. So look at where we are now in the week. We are in the 11th week. We have, after this, 4 more lectures to go, 2 on interpretation of solids and 2 on development. Okay, so you'll have to bear me for 4 more hours and the NSEM exam. So this is the example problem that you will be solving in lab number 11, I believe. Lab number 11? Okay, yeah. So you already have the solution. If you don't, I'll go through it. So we need to figure out the view of this object and the top view of this object. And the trick is that 2 of the planes that you see, they are inclined. Okay, they don't get aligned with either the horizontal or the vertical, so it becomes a little difficult for you to draw the conventional orthographic view of this drawing. So what you do? You take the help of auxiliary plane. Okay, get the true shape of the object on these planes and transfer that shape correspondingly in your front view and the top view. Okay. So the center part of the object, it's not very difficult to draw, so maybe I'll just run through that. So it's a block, okay, some dimensions, some protrusions coming out from the right, from the left, and of course this angle is given. I think it's 45 degrees, so this angle is given. So perhaps I can get the thickness of the planes on both ends. Okay, so this is the base, this is the primer, and then I project some features in the top view that I can. So from the top, it's going to be a hollow box in a way with some thickness. All right, so hidden lines, center line, and if you want to, and you have to do that. So to be able to capture the true features on this plane and on this plane, you have to draw, those features in the corresponding auxiliary views. Okay, so if you flip this plane by 90 degrees, you'll get the true features here, and likewise if you flip this plane by 90 degrees, you'll get the true features over here. So here it's pretty much like a slot, and well, it's a semicircular slot, and here you have a T slot. So let's try to get that. Yeah. Where? Here? Here? Why is there a center line? Should be there, should not be there. Huh? Should not be there? Why should it not be there? Okay. Okay. It should not be there. Do you have an eraser? Yeah, well, just erase it. So ignore that. Okay, ignore that. All right, so coming back to the true features on that plane. So this length is going to be 30. From here to here is 30. This would be about 40. So this total length is 40. So you have to draw a few arcs on both ends, here and here. Okay, so get this slot. Not very difficult. Get the arc, and you have the true features on this plane, on the auxiliary plane. The second one, is it okay for me to have the center line here? Huh? All right. And of course, so once we have this thingy here in the auxiliary view, I'll have to come back and update my top view, update my front view. So I'll have a dashed line corresponding to this feature, and on the right hand side, again something very similar. Drawing that is not going to be very difficult. Okay, so it's a T slot that we have, and once I have this auxiliary view, then I come back to my top view and I update that. So I have corresponding hidden lines. All right, so is it okay for me to have a center line here also? Huh? Yes or no? Why not? Why? Symmetry. So this center line is representing symmetry. All right, so is my front view done? Am I done with the front view? Am I done with the front view? Or do I need to do something else? Yes? No? Huh? No answer? Am I done with the front view? Good. Not yet. How about this line? How about this line? What would this line correspond to? Huh? No? Which one? Which one? This one or this one? This one. Should it be hidden? Should it be solid? I'm okay. I'm okay, right? Should be hidden line. Okay, fine. So yeah, so because you have flipped this thing like so, na? And likewise, you'll have a line corresponding to this. Okay. So once your auxiliary views are finalized and through with, start working with the top view, and this is where I would need your attention. So pay attention. This is where things get complicated, because transferring these features from here to the top view is a little tricky. Okay, so first get the projections, match the projections. Yeah, so corresponding to this corner here, you'll be seeing a solid line. Corresponding to this one, you'll be seeing a dashed line. Center line, should I have a center line here? Because the object is symmetric with respect to that. Okay. Pay attention. We'll transfer these features onto this feature. Okay. Now you must have studied something way back, maybe 5 or 6 lectures ago, how to do that. Something very similar. So this is one of the views, a hinge line, second view, third view, right? So do you recall how do we transfer distances? Do you recall how do we transfer distances? Exactly the same thing. Okay. All right. So I'm going to be projecting this feature up, and this is the tricky part. I have not yet identified the hinge line that would separate these two features. Okay? And how would I want to do that? I already have the hinge line here, because if I don't do this correctly, then I'll mess up the transfer of features from this auxiliary view to here. Okay? Do you want to stay or? Okay. Yeah. So you have to be able to locate this hinge line properly, because if you don't, then you will mess up your transfer of points from this auxiliary view up to this top view. Now what I do is I measure with respect to this hinge line. From this center line, I locate this point over here and I draw a little hinge line. Okay. Now this hinge line is local in the sense that this hinge line represents only the relation between these two views and okay. Now once I have located the hinge line over there, rest becomes simple. I'll measure this distance. I already have the projector up over there. I'll transfer this distance over there. Okay. Likewise, I measure this distance. I transfer this distance over there. Okay. And what am I doing? Yeah, now I'm measuring this distance. My projector is here, so I'm projecting the top face now. Okay, so I'm projecting this face now, not this face. Okay, measure distances, transfer distances. Okay, and then project this guy up over there, measure this distance, transfer that distance. Once I have all those distances over there, it's easier for me to make this T. Yeah?
Why are we drawing in the right way using the original dimension?
Why are we?
The one is the length dimension will not be shortened by any factor. Really the breadth factor is shortened by any factor.
You can?
The breadth factor is shortened, the breadth is shortened by the factor because of the detail.
Yeah.
So that I can get from the projection in the front view.
Yeah.
And the one in the left direction remains the same.
So what you're saying is these distances, they remain the same. Is this what you're saying? That these distances remain the same. It's this distance that gets foreshortened. Huh? Yeah, you could do that if you want to do. If you want to draw this directly, you could do that. So I'm just explaining the procedure. The procedure. For a little more complex looking objects, it may not be feasible for you to draw it the way you want to. Okay. All right. So having worked on the top face of the object, now working on the bottom face of the object. Exactly the same thing. Okay, a part of T will be visible and a part of T will be invisible. So this part inside the previous T is going to be visible. Okay, this part is not going to be visible. So it's going to be shown using hidden lines. Okay, so this part of T is right there. Where am I? Okay. Now, how about this arc, Kevin? that you cannot draw directly. So you'll have to take projections and you'll have to measure distances precisely. So look at this arc, transfer this arc over then from the top view, from the front view to the top view. So discretize that arc into a number of small segments. Do you see these? Do you see these lines? Do you or you don't? You don't. So yeah. So there are a few lines over here. So discretize this arc. Measure distances from the hinge up to different points on the arc. Draw the projectors from here. Measure these distances, light green lines. Transfer them over there. Okay, here. Right? So once you get those distances, then it becomes a little easier for you to draw the arc. Okay? Likewise, on the top, draw the horizontal lines. Okay? Is this going to be visible or is this going to be hidden? Visible. How about this? Is this going to be visible or is this going to be hidden? And would the arc corresponding to this plane here be shifted to the left, right? Shifted to the right. So once you have gotten this arc over here, if you're smart, you can just directly shift that arc to the right by the requisite amount, or you can take the projections from here, okay, and get that arc at its proper location. So the top view becomes a little difficult to work with. Okay. Likewise on the left, same thing, exactly the same thing. So you have this edge drawn. Okay. So the edge corresponding to this corner will be visible. How about this corner? Visible, invisible, hidden. And then start taking projections, start measuring distances, transfer distances, and get your top view in order. This is for the arc. Likewise, on the top, that part is going to be visible. Okay. How about this arc? Exactly the same procedure. Discretize this arc into a bunch of points, measure distances from this arc from the hinge line, and transfer those distances onto your top view. Likewise on the top, join these guys. This is for the top face. This is for the top face. How about the bottom face? Yeah? Why is this local and why is this local? True. Then I'll have to be a little careful, because then I'll have to figure out the appropriate or proper location of this hinge line and this hinge line. So what I'm saying is, if I locate this hinge line independently, if the location of this line is again independent from this, okay, then the choice of this would depend on how I have located this hinge line, and the choice of this hinge line would depend on how I have located this hinge line. You can. Can you directly measure distances? So if you don't want to measure the distances from this hinge line, and rather, yeah, I'm coming to that. So let me see if I've gotten you right. So if you don't want to measure distances from this hinge line, rather if you want to measure distances of these points from this edge, okay, you can use this edge as reference and transfer distances accordingly. Is this what you're pointing at? Is this what you're aiming at? Or Yeah.
But in the upper figure, we measure distances from the hinge line that we have drawn, but we draw the hinge line as a complete part instead of making it complete. We measure distances from this line, but instead of showing this as the hinge line, we show that there is a common hinge line for the whole view.
You can, which is what I'm saying. You can, but you'll have to be a little careful. So if you want to show a common hinge line that separates this view from this view, you can. But when you do that, the location of this hinge line and this hinge line, they will be related. This is what I am referring to. So after the mid-sem break, you're going to be working on this example. So try it out. Try it out. So if you choose to represent both these hinge lines by a single hinge line, then make sure that these distances, they are properly correlated. At this time, they are independent. You see what I mean? Or maybe we'll discuss this. Yeah. All right. So how about the features on the bottom face? This face here. Identical procedure. Okay. So of course, like you see this arc over here, you will also see something very similar at the bottom face. But if you look at the top view, this arc will get shifted inward. Okay, and since this is at the bottom, this would be shown using hidden lines. Likewise, the inner slot over here, this will get shifted inward corresponding to the bottom face. Okay, and it will be shown using hidden lines. Okay, did I miss out on anything else? Is everything there? Sure? All right. So why? Because I'm leaving you 10 minutes earlier? Yes, sir. You're too bored with TA 101, is it? Yes, sir. Too bored with TA 101? Yes, sir. Why are you bored? Huh? Time consuming? Well, if I have made you work a lot, I'm not sorry about that.
They should increase the credit. They are only 90 credits for TA.
No, but it's not their fault, it's my fault. I'm making you work harder, nah? Come on, you're learning so many things. Isn't it? I'll give an example. So think about this. What? Come on. You are fresh from your JEE exam. You know SL Noli by heart. You know all your physics books. Resnick Halliday, is it? Or Resnick Halliday, Irudov? Or is there any new book that I'm not aware of? S.C. Verma. Okay. Oh yeah. Fine. So given 3 points on a hyperbola. Given 3 points on a hyperbola, let's say this is your axis and your hyperbola is symmetric about this. How do you construct it? hyperbola. Pardon my drawing. I mean, it should have been more like that. Given 3 points on a hyperbola, how do you construct it? I'm not interested in the algebraic solution. I'm interested in the geometric solution. How do you construct that? Huh? See? Think and analyze. If you have done your TA 101 well, maybe I can expect a solution from you guys in another 5 or 10 minutes. But if you have not, they're symmetrical. But I need only one of these points, not two. How do you construct this geometrically? Given 3 points on a hyperbola. Ish. What does it mean? What does it mean? Ish. Ish. Then it should have been ISH. That's ish. Huh? Ish. And what is? Yeah. Yeah. Come on. You have a hyperbola problem to solve. So I have smart people in front of me, people from computer science, electrical, mechanical, mathematics, BSB. All of you guys have done SL pretty nicely, I mean pretty thoroughly. 3 points on a hyperbola, how do you construct it geometrically? Yeah? Huh? French curves? Come here. Come here. Come here. Yeah. 4 more guys to lift him. 4 more guys to lift him. French curves. Why not use a compass and draw an arc, man? Huh? They'll be more accurate? Yeah, alright. I'm not saying that. Anybody with a solution? Yeah? Step out.
So we construct this
Triangle?
And we make the offset, find the offset of triangle greater than hyperbola.
You have a piece of chalk? Take a piece of chalk and explain it. This point will lie on a hyperbola. Well, these 3 points are lying on a hyperbola itself.
3 points are given on the hyperbola.
Yeah. So these 3 points are already there on the hyperbola. How would this point lie on a hyperbola?
Find the offset of the triangle lies on the hyperbola. It's a property.
Yeah, fine. So construct it. Construct it. Yeah, anybody else? Anybody else?
Perhaps it's like this, that take any axis, take the mirror images of these points into a
Okay.
So the points where they intersect, the corresponding concentric circles, those will give the points to the corresponding hyperbolars.
Sure. Most probably. So can you verify that, and
That will take some time.
that'll take some time? Okay. Okay. What? There is. There is. There is.
Using that point, we can
There is a very obvious solution. Yeah?
Now, how you say that opposite of a triangle lies on hyperbola. So we got 3 points. Now we got 4 points there. And these 4 points and 4 lines.
Now I guess I should be saying a Tier 101 is so difficult. I have absolutely no idea about these methods. Alright, so when you return, and please do return after your mid-sem break, we'll talk about these interesting aspects of TA 101, intersection and development. So it's pretty fun, a lot of work, but pretty fun also. So happy Holi, go home,